Okay, a very good morning to everybody. So hopefully you all have already taken your breakfast. So today we are going to continue from where we stopped yesterday. So yesterday we stopped at section A, question number 20. We are going to continue with question number 21. So question 21 sounds like this. Chromium 3 ions form several complexes with different ligand. 5 centimeter cube of 0.1 mole per decimeter cube of aqueous solution of chromium 3 ion is mixed with different volume of 0.1 mole per decimeter cube aqueous solution of ligand L. A graph of relative intensity of the color complex formed against the volume ligand L is shown below. So this is the graph. So what is the ligand L? So in here, you need to calculate what is the mole of the ligand towards the solution. So in here, because you have mole of the ligand, okay, mole of the complex ion, mole of the chromium, you use MV over 1000, so it's 0.1 multiplied by 5 over 1000. So you get 0.0005. Okay, and then in here, if you notice carefully, the volume, the maximum volume required in here is 15, isn't it? So the mole of the ligand is equals to 0.1 multiplied by 15. Okay, divide by 1000. So you get 0.0015 mole. So in here, you can see that the ratio of the chromium 3 plus to the ligand is 0.0005 to 0.0015. So it's 1 to 3. So that's why in here we said that the ligand in here is 3. So therefore, usually this chromium will form a hexadentate. Chromium usually will form a coordination number equal to 6. So therefore, if you have only 3 ligand but 6 coordination number, that means this 3 ligand is a bidentate ligand. Okay, so that is why in here the complex expected is to be Cr, NH2, CH2, CH2, NH2, because chloride ion is a monodentate, EDTA is a hexadentate, ammonia is a monodentate, and this ethylene diamine is a bidentate. So that is why the best answer in here is B. Okay. Okay, then this is 21. Then we continue with 22. Ziegler-Natta catalyst is used to produce high intensity of the polypropylene because titanium 4 ion is the catalyst that have the main reason why Ziegler-Natta is a catalyst is to form the chemisorption bond with the alkene. Therefore, it must have empty d orbital for this to happen. Okay, so it does not change its oxidation state. It's just making use of the empty d orbitals to provide active site to form a temporary bond between the the titanium and also the alkene. Okay, so you learn more detail when we go to semester 3 later. So that is for question number 22. Then we continue with question number 23. Transition element has variable oxidation state in the complex. What are the correct oxidation state of iron in the following solution? So if you have FeC2042 and SCN3 minus, so ethylene diamine is C2042 minus. Okay, then I made a mistake in here. I use C2O4, so C2O4 has -2. This C2042 minus ethylene diamine. But in the replacement of the calculation, I replace it correctly. It's x times 2 times plus 2 plus 2 times -1 is equals to -3. Therefore, x is equals to +3. Okay, and EDTA has a charge of -4. So y plus -4 equals to -2. So y is equals to +2. So it will be +3 and +2 respectively. Okay. Okay. 24. The element X has a proton number 25. Which of the following statement is true? So 25 means that X is a transition element with the valence electron 3d5 for S1. So it is from D block. Hence, it has a high density, form colorful ions, and also has the highest oxidation state of +7. Okay, so not +6, so it's +7, and we can form the formula XO42 minus. Okay, so the best answer in here is 1, 2, and 4. Okay, okay, so that is very straightforward for number 24. Immediately we go to question number 25. Which of the following ligand is a bidentate? So this one you have to memorize by yourself. Which one is a bidentate ligand? So oxalate ion C2O42 minus and ethylene diamines are examples of the bidentate ligand. So the answer is 1 and 2 only. If you want to know how does the Lewis structure looks like, in here I also provide you on how does both of them looks like, so that you have a slight idea on why is it that they are bidentate ligand. Okay, so this is how both of them looks like. So making use of the non-pair electrons in each of their respective oxygen ligand donor atom to form the bidentate ligand to the center metal ion. Okay, okay, so that is how both of them looks like. So that is for 25. Then we move to 26. Chromium has the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1, which ion does not exist. So in here, you need to calculate each of the oxidation state for chromium. So in here, because of the valence electrons for the chromium in here is +6, okay, so you can only have a maximum of +6. So therefore, you cannot have +7. Okay, so the best answer in here is A. Okay, then we goes to question number 27. Zinc 2 ion form white precipitate ZnOH2 with aqueous solution of ammonia. The white precipitate dissolved in the ammonium chloride is added to it. Which of the statement best explain these observations? Number one, a soluble of ZnCl2 will form. So actually, the addition of the NH4 decrease the concentration of the OH minus. So because the NH4 will react with the OH minus to form ammonia plus. This is a neutralization where it will form like this. Let me draw out. The purpose is because this is adding the NH4 will decrease the OH minus because the ammonia aqueous solution will somehow react it to decrease this one. So that when you add this one, equilibrium will shift to the left and right. Okay, so concentration of the OH minus will decrease. Okay, so that is the reason why we add this one. So that is how you explain the formations of the application of the NH4. Okay, so that is for number 27. Then 28. So which reagent when added to excess aqueous solution containing copper 2 ion will produce a pale blue solution as a final product? This is something that you have to memorize because adding ammonia, you form the complex of the CuNH3,4 2 plus. This is a dark blue solution. Okay, so number 2, this one is EDTA, so this is the answer. And when you add sodium hydroxide, you form copper hydroxide, which is a blue precipitate. Okay, and then you add the potassium hexacyanol, you form CuCN4 2 minus. CuCN4 2 minus, if I'm not mistaken, is yellow in color. I forgot already. Probably yellow, if I'm not mistaken. Later I'll confirm that with you. Okay, so this one is aqueous potassium ethylene diamine tetraacetate. Okay, so that is the effect of adding this potassium ethylene diamine tetraacetate to copper ion. So you form a pale blue solution. Okay, okay, so that is for number 28. Immediately we go to question number 29. Which of the reaction equation and catalyst correspond correctly? So ammonia, you don't use V2O5. So ammonia you use iron. SO2 plus O2 give to SO3 is iron. No, you use V2O5. So it's the other way around. This one is the formation of high density polypropylene. You use TiCl4, and then the hydrogenations you use platinum as the catalyst, or nickel also can. So that is the suitable catalyst for it. And then number 30, an aqueous solution of iron 3 plus ion react with excess cyanide ion to form a color soluble complex. Which statement is true? Cn minus act as a Lewis acid. It act as a Lewis base because it donates the lone pair electron. So A is wrong. So Fe3 plus ion is reduced to Fe2 plus. No, there is no changes of oxidation state. So B is also wrong. Color of the complex ion form is green. Actually, it's yellow. Okay, and then the formula of the complex is FeCN63 minus, which is correct. So the answer is D. Then we go to question number 31. Which species does not act as a ligand in the formation of the complex? So in here, only ammonium cannot use as a ligand because ammonium ion don't have lone pair electron. So therefore, it cannot act as a ligand. The rest of it can. We can still have the lone pair electron in it. Sorry. Okay, so you can have a lone pair electron and a nitrogen. for B, it is chlorine, you have one pair electron. And then the OH minus, you also have one pair electron. So all of them can act as a ligand except for NH4. Okay. Then number 32, which of the following are bidentate ligand? I think this is very deja vu, isn't it? Okay, so 32, I already asked that, so shouldn't be much of a problem. And for your information, this is thiocyanate. I draw wrongly, sorry. Thiocyanate is supposed to be SCN. And the ligand donor atoms belongs to sulfur. Sulfur. So sulfur is the one that will form the, you can calculate from the formal charge, right here. Okay, and methylamine is a monodentate ligand. Okay, so that is for number 32. Okay, so 1 and 2 only here. Okay, so that is for 32. Then we goes to question number 33. A colorful compound complex Z is formed when the following reaction is added. So FeH2O6 3 plus SCN minus give FeH2O5 SCN2 plus H2O. The formula of the complex can be determined by mixing equimolar in the varying proportion and then use a colorimeter to analyze the intensity of the color produced. Which of the following is correct? Number 1, ion Z is a red color. Yes, this one you have to memorize. FeH2O5 SCN2 plus is red blood color, which is used to identify iron 3 ions in low concentration. Okay, so number 3 is also correct. So as the ratio is 1:1, therefore the color intensity is maximum and is equal volume. So number 2 is correct. However, this is a displacement, but not redox reaction. The oxidation state still remain as a +3 oxidation states. Okay, so in here only 1, 2, and 3 are correct. So the best answer in here is A. Then we go to question number 34. Table below shows the possible oxidation state of 5 D block elements in the periodic table. The elements are represented by the letter which are not the actual symbol. So look at the tables in here. Okay, which of the following ion is not likely to exist? So in here we have no choice but to calculate every single oxidation state for all the species involved. So you shall have for the rest of them. Okay, so phosphorus, you can have a +3, which is A is correct. So Q, you can have a highest oxidation state +4. So QO3 minus 2 minus, sorry, this is 2 minus. I write wrongly, typing error. It's 2 minus. So Q is +4, which is also correct. R is R2O5 2 minus is also +4, so it's correct. But S you can have highest +7, but in here you have the +3 oxidation state cannot be formed. So in here S form +3, so that is why S in here S2O4 2 minus cannot be formed. So with that, that is the answer for number 34. Okay. Okay. Then immediately we check question number 35, shall we? Okay, which ion complex is or are octahedral shape? Okay, so hexa, aqua, cobalt, two ion. So it's an octahedral complex. Hexaamine also is an octahedral complex. As long as your coordination number equals to 6, then definitely it's an octahedral. Bis-ethylene diamine copper 2 ion is a square planar. Okay, so this one, the structure, okay, I draw for you. You can have CH2, and H2. So we form Cn here. H2, CH2. Teacher, how do we know which is what shape? This one you have no choice but to memorize a bit. Okay. And then ethylene diamine tetraacetate, this one is EDTA. EDTA is a hexadentate, so definitely is octahedral structure. So it's here is 1, 2, and 4. Okay. So only C, bis-ethylene diamine copper 2 ion is square planar. Okay, so 35 is what? 36. Which of the statement concerning of transition metal is correct? A. They are the only metal which anhydrous chloride have covalent bond. No, they are only metal which have color ion in the aqueous solutions. Not only transition metal, there are also some others which can also give color ions. There are only metals which has more than one valence electron oxidation state. No, they are they are not the only metal. They are not the only metal, so C is wrong. And they are the only metal with complete 4s orbital. This is not true for chromium and copper. So the best answer in here is B, not C. So yeah, I made a mistake in here. So the best answer in here is B. Okay, pardon my mistake in here. Answer is B. There are only metals which give colorful ions. Okay, because only transition metal can give colorful. Main group metal cannot. Okay. Okay, so that is for 36. There we go for 37. Which of the following chemical reaction does the transition metal compound behave as a catalyst? So in here, you have to try your best to understand. In the formation of ethanol to ethanol, you use acidified K2Cl2O7, so it is an oxidizing agent, not catalyst. So 1 is wrong. In the formation of oxygen from hydrogen peroxide, you use iron trihydroxide. It is using as a catalyst. Then the chlorination of benzene using chlorine and iron trichloride is also used as a catalyst. And then the formation of nitrogen monoxide from ammonia use platinum. It is also uses catalyst. So in here, the 2, 3, and 4 are uses catalyst. So only 1 is oxidizing agent. This one is a little bit disadvantageous because you don't know, especially for number 1 and number 3. This is the organic reactions that take place. So probably some of you don't know. So that is why you have to try to understand. You have to memorize a bit here and there. Okay, so that is why you need to do a lot of practices. 38. When a drop of ammonia is added to CuNO3 a pale blue precipitate is first formed. This precipitate, when dissolved, excess ammonia aqueous solution is added, forming a deep blue solution. Which process do not occur? So in here, when you add ammonia aqueous solution, you form a blue precipitate is due to the formation of CuOH2. And then this CuOH2 will dissolve in excess to form CuNH3 plus, according to this equation. So in here, of course, when you form complex, there definitely is a dative bond. And if, of course, they form complex ion, B is correct. Precipitation of the copper 2 hydroxide is also formed in the result. However, there is no reduction of the copper ion. So this is the only observation which is not present in these reactions. So 38 is D. 39. Hexa-aqua iron 3 ion hydrolyzed in aqueous solution shown below. So this is the equation. Actually, I shouldn't put this plus. There shouldn't be a space. Sorry for that. Okay, so 1. The corresponding ion FeH2O62 plus is less to undergo hydrolysis. This is correct, and usually only this what? Iron 3. I think I typed wrongly. It's supposed to be iron 3. Yes, my mistake, because in the question I typed wrongly. Okay. It's less likely to undergo hydrolysis. Yeah. Okay. Number 1 is correct because iron 2 is less likely to undergo hydrolysis. Number 1 is correct. And then number 2, iron undergoes the changes in oxidation state, which is not true. Okay. Iron does not change oxidation state, right? It is still +3. Yeah. Okay. Hydrolysis is favored to a low pH value. So when you have a low pH value, equilibrium will shift to the left. So that is why it is not true. And the solution changes from yellow to green, which is not true because there are no changes in oxidation state. So we are looking for not true, isn't it? So 2, 3, and 4 are not true. So the best answer in here is D. Okay, then 40. Elements of the outer electronic 3D4S are expected to have 1 colorful ion, definitely, form complex ion, definitely, has low melting point, wrong, and can form the ion with the formula XO4. So XO4 has an oxidation state of +7 because 3D5O4 4S2 has 7 valence electron, so you can still form XO4 2-. Okay, so the best answer in here is 1, 2, and 4. Okay, so with that, that is all for the section A for this chapter 7. Then we shall straight away continue to section B, which is the structural questions. Okay. Okay, so with that annexation, let's have a look at the structure question I prepared for you. Okay, so let's have a look together. So let's start the structure question number B. Question number 1. Table below shows the formation of some of the elements inside the D block. So complete the table by filling valence electron in the color. So scandium 3+, because the valence electron, scandium originally has the valence electron of the 4s2 3d1. So when you remove 3+, so it becomes valence electron is 1. Iron has the original configuration of 3d6 4s2. So when you remove 3 ion, it becomes 3d5. And then copper has the original valence electron of 3d10 4s1. Okay, so when you remove 2 electron, 1 from 4s, 1 from 3d, so you must have 3d9. Okay, and then the color of aqueous solution, because it's complete field, so it is colorless. Fe3+, you have to fill in either yellow or brown. So both are accepted, and then copper is blue. Okay, then number 2, explain why scandium ion has the color stated above. So because d orbital is empty, so there are no dd transition occur inside empty d orbitals. So that is why it is seen as a colorless solution. B, iron can also present in an iron 2 ion. Right, the electronic configuration of iron 2 ion explain whether iron 3 and iron 2 is more stable based on the electronic configuration. Okay, so in here, iron 2+ has 1s2, 2s2, 2p6, 3s2, 3p6, 3p6. So Fe3+ is to stay more stable than Fe2+ because of the half field orbital has extra stability. Okay. So this is how we are going to explain for question number 1. Okay, so hopefully you all can understand how to answer it. So immediately we go to question number 2. Cisplatin is the cis isomer of PTNH3Cl2 complex that is used as anti-tumor agent. So give IUPAC name for the cisplatin. So in here you should be able to name as diamine dichloroplatinum 2. Number 2, draw the molecular structure and the shape of cisplatin. So this one you have to memorize because this is quite common in Stpm content. So you must know that it is a square planar which looks like this. Okay. Number B, aqueous copper 2 nitrate react with a small amount of ammonia to solution to form a blue precipitate. When dissolved in excess ammonia, the blue precipitate dissolves to form a dark blue solution. Number 1, using suitable equation to explain the formation of the blue precipitate. So the blue precipitate is due to the formation of the COOH2. So according to the equation, CO2 plus 2 ammonia in aqueous solution, so you form COOH2 plus NH4 plus. So that is the reason why you see the blue precipitate in here. And definitely asking this will definitely ask you what makes the blue precipitate dissolve in excess. So the blue precipitate dissolve in excess is due to the formation of CONH342+, because ammonia is a stronger ligand, so it can displace the water easily. So COOH2 plus 4NH3, so from CONH342+ plus 2OH minus. Okay. So this is how we are going to explain the formation of the CONH342+. Okay, so with that, that is for question number 2. Then we move to question number 3. Compound X2O3 are added to glass to give a color of a blue solution. So this is a very typical color, a blue color. Not many elements can form periodic table, and usually it is the cobalt added to the glass to give the blue color of the glass. State which blocks does in the periodic table does X belongs to? It belongs to D block. The number of valence electron of X 3+ is 6. So write the valence electronic configuration of X. So if you have 6, usually X will be 3d6. So when you that is how X3+ has 3d6. So therefore X in here will be plus 3 electron. Now when you add back 3 electron, the first 2 will definitely be added to the 4s. Okay, and then the extra one will be 6 plus 1 in here. So therefore 3 electrons. So therefore you have 3d7 4s2. Number C, explain why X3+ is blue color. So in here they are asking you to explain why is it colorful. So it is because of the splitting of the d orbital. So splitting of the 3d orbitals occur inside the transition element. Okay, so excited of the 3D element absorb energy from visible light to the spectrum, or you say DD transition take place. Same meaning. Okay, so in here, because you want to see oh, okay. So they expected this answer. Okay, so you have extra point that you have to make, that excitation of the 3D electrons absorb energy from the visible region and cause DD transition. Okay. Okay, sorry for that. Because uh, this is how you should answer. Okay, and then D, what color is absorbed by X3 plus? This was supposed to be one color, 1 marks only. Yeah, sorry for that. You should also have 1 marks only. Okay, it's orange. That's why you see as the blue, and name the element X is cobalt. Okay. Okay, so I guess with that, I will end my lesson for today. Okay, so tomorrow we continue with 5 more structure and 2 more essay in our next lesson. Okay, so I guess that is all for our lesson today, and I'll see you all in our next week lesson. Okay.